Okay, I can't talk till I'm sure I have the mic right. I think I do.
Coming
Yeah,
through loud and clear.
you
Good.
can hear.
Okay. And of course, it chose the wrong one, by the way. It's like every time I switch between Zoom and Teams and whatever today, it's like the random new thing. Um, so it looks like Yogesh had something urgent today, so he asked me to drive things. So what I was thinking we could, well, one thing I selfishly want to do is get feedback on the drawing update that I made. I've been editing it, and Vilas, you gave me feedback, and I've tried to incorporate it. I'd like to work on that a little bit today. Are there other opens that we should consider?
I gave Anil the heads up. So
I'm sorry.
I was saying I gave Anil the heads up
Oh,
Yeah,
good,
during
I'm
the
good.
just
last meeting.
yeah, I'm just catching up. I'm trying to open the document.
I
Yeah,
think
that's what exactly you're going to review right now, right, Drew?
well,
Changes?
that's one thing I want to talk about today. Yeah,
Sure.
and another thing we did while you were gone is we cleaned up the different use cases, but I don't, hopefully it's not too controversial. I mean, it wasn't. We came to an agreement and updated the document. Um, so if there are no other opens, I'll just jump in. All right, let me make sure I'm sharing the right tab. Okay, sorry for the scrolling, but okay, the old drawing and the new drawing. And it's a little cleaner. I'm still cleaning it up, but Vilas, I tried to do what you said the best I could. Where I think Vilas is here, right? I thought I
I'm
saw him.
here. Yeah.
Okay, okay. So Vilas, you told me, hey, it would make these look the same in terms of um, the flow for GPUs and CPUs. There's some commonality, and then show that this is also doing the same things that the BMC does. The thing I wasn't quite sure about was your last comment about kind of like color coding where the vendor stuff is. And I think I understand the gist of what you're saying, like in like the high level idea, but what I don't understand is um, we have vendor code here, obviously, with drivers. I mean, that's like what a driver is usually. But the IMA, I don't know, like, is there a plug? Like, should I put a plug in and the plug-in is vendor code, or this whole box obviously isn't green because the IMA is a bridge between stuff on the machine to whatever the hyperscalers control plane is.
Well, I think at some level, the BMC side, that REST API agent isn't all vendor code. Like only the plugin is potentially vendor code, right? Same as the IMA, right?
Yeah, yeah. I
Right.
actually,
Yeah.
as I stared at this, I was wondering that too. So I agree with you.
Yeah.
Yeah,
Yeah. I mean, so yeah, I think this is closer, right? But I think basically, if you have the plugin be the vendor code on the BMC side, it lines up to the vendor code on the OS side, right? Which is basically a way to transfer for the RAS API agent to
yeah.
communicate down to the devices. Um, and then you've got this BMC web redfish thing here. Presumably there's some in-band protocol agent that's running that's going to have a RAS API agent from the IMA to the data center as well. So I would just include that, right? And then last thing, the BMC errors should look just like the CPU and the GPU, right? Like, or the BM, right? So like, I think then everything lines up one-to-one effectively, right? I mean, I wish I could. I don't know that I can actually edit this. Like I've tried editing these docs and I can't seem to. Um,
Really?
yeah. Right, but
Okay.
like you see what right now, like if you add a box above the IMA to talk to the data center, now you've got the exact same set of boxes on both the BMC side and the OS side. And so just making them line up visually, I think would make sense, right?
Oh gosh. That's a tall order. I'm apparently having trouble. Gosh, things hate me today.
Yeah.
I
I've been
think this is good, but this picture looks like so complex, people.
Yeah.
well, it's hard to edit, but it's way simpler. I mean, this is
Yeah.
okay. I'll work on this a little bit more, but I think this is what I think I just heard you say, that plugins are vendor code, the RAS API agent. Now,
Yep.
now these two look very close.
That's right. Yeah. Yep.
Hey, one
And
quick question. What is the definition of RAS API agent here? Like, are we talking about an endpoint that is hiding other endpoints behind, or like how do we define that?
yeah, I think we had this, was it last week we had this discussion? I think he initially had an endpoint written, but it's
I was not
the,
here.
I'll just say it this way, the RAS API is not sufficiently stable that I think we should say, endpoint versus something else, right? Like we, so, maybe an endpoint is different than an intermediary point than an originator, but like, we just don't have that, fully defined yet.
The entity that understands RAS API data structure.
That's right. That's right.
Okay.
Exactly. Yeah.
Okay, I mean, and the change you just suggested I like what I just did, and I think you told me to do, but I like it. It's good. Are we on the right track?
Yeah. So I think where you've got the redfish box in the BMC, right? I don't know what the OS side would use to talk to the data center, but presumably there's some equivalent thing, right?
Well, it's kind of. I guess I view the IMA as the bridge, right? It's the bridge from the host to the control plane, and it can be whatever bridge it needs to be for that user.
But it's talking some protocol to
Yeah,
the controller.
but my point is, it's not. I mean, the IMA could be a gRPC, it could be Redfish, it could be,
Yeah.
it's whatever the language whatever protocol this control plane speaks, it will be the bridge to it, and who knows what that is? It can vary.
Yeah. I'm just saying there should be an equivalent, where it says BMC Web Redfish, right? There should be some equivalent box above the IMA on the OS that's, got a RAS API mapping to talk whatever that language is to the data center.
Maybe I'll call it hyperscalers control protocol or something.
Sure.
And then we just explain it as whatever the hyperscaler chooses.
Yep, that's right.
Okay. So
because like Redfish is also just like whatever the hyperscaler chooses, right? It's just
it is.
Yeah.
Yeah,
exactly.
Yeah.
I mean, this is the one I was thinking in my mind. We can equivalently call out of band agent, and then we can define what that means.
That's right. Yeah.
Right.
Yep.
Because that agent is again going to be CSP specific, how it is implemented. It could be just a polling, could be event based, the event registered to the CSP.
Well, I think what he's saying is the CSP as a protocol is. I mean, this is what you're saying, right?
Yes, that's what I'm saying. Yeah. I mean, and I think what Anil is saying, and I tend to agree with this, is for a drawing like this, I would not specify Redfish in the BMC. Not all hyperscalers necessarily use Redfish, right? While it is relatively common, you could just say.
How about EG Redfish as an example?
Well, so again, I think okay. My recommendation would be just say CSP protocol, and then just say RAS API protocol mapping. That's the same, you have the same box on the BMC and the OS side. In the text that explains the FICR, you could say, a very common implementation of this on the BMC is Redfish, right?
Well, BMC Web is red. I mean, I think it's more intrusive to change it. Because we have so I guess you're saying I could have CSP and and then this would be BMC CSP interface or something.
Yeah, that's something. Or
Let me
just
think
CSP.
about
Yeah, just think about it. Yeah.
Okay,
Like,
I'll think about that and try to figure out how to.
yeah, and mostly true, right? Like it doesn't depend on having, none of this depends on having redfish. While it is the most common used thing, it's not necessary, right?
Well, let's just say that some of the key hyperscalers want it to be redfish because that's what they've chosen. But I agree with you.
Yeah,
If another company came along and said, no, I insist on gRPCs,
sure,
it will
exactly.
work.
Right?
You
Yeah.
just need a mapping. Yeah,
Yeah.
I'm aligned with you.
Yep. Cool.
So also to keep parity with the color coding, right? The CSP protocol line is pink. So should the HTTPS also be pink? Like,
No, the pink was
isn't
the
that
in-band
what you
stuff,
want to
right?
see? Oh, it's for
One second,
in-band.
one
Okay,
second.
so pink and blue is in-band versus out-of-band. Okay. So I
So
was thinking that because the cloud provider control plane is a common entity with which either the in-band or out-of-band will talk to.
Oh,
So
true. Over on the right here, this is both. Yeah. Well, go ahead, Anil. What were you going to say?
yeah, so looks like you drew another box called CSP protocol. It's not really a box. It's just a explanation of this arrow, the purple arrow.
Oh, I see
We
what you're
shouldn't,
saying.
yeah, we shouldn't call that as a, yeah.
So you're saying this is what you want, and then just get rid of the border of that box, right?
Right.
I mean, that's fine with me. It doesn't matter to me.
Yeah.
But then it doesn't look exactly like the.
Well, so your HTTPS, right? Going to control plane. This is REST API, is it? It's a HTTPS secure connection, correct?
No,
I mean, we can make
that's redfish. Yeah.
Yeah, this is redfish. Redfish is over HTTPS.
Yeah, but so even CSP protocol, the way at least is a sort of a SSH or ESS, whatever, HTTP protocol used here as a baseline.
I mean, you could do gRPCs here too. This is Vilas's point, and that's what I've got to go rework here.
Yeah. The question I have, Drew, is do we really have to be calling out HTTPS here, or can we just simply say CSP protocol?
No, I think it's CSP protocol. That's what I'm saying. I'll put it for now, but that's what I feel like Vilas gave me the action item to figure it out how to make it all fit.
Now we are good, right? Because then I think connecting from the machine to the CSP control plane, right? That's CSP protocol.
Yep.
And then yeah.
Question.
Yep.
What is CSP protocol? Is it APIs we are talking about?
No, it's red.
Just CSP specific implementation.
Right. Yeah, it's whatever you all use. It's just not standardized. Maybe you all use the same thing, but it's not, a requirement.
Actually, no, Vilas, hold on. It is not required by the RAS API to be standardized, but we might standardize protocol mappings for it and have that suggested as a best practice, right? So
absolutely, yes.
We can't say this is how we want to use RAS API over Redfish. That's no problem. We can do that, and that can be kind of a standard. I mean, no big deal, right?
No. That I agree with, right? But so standardizing how RAS API works over Redfish or over gRPCs or whatever, that is definitely something we should do, will do, right? Requiring a CSP to use Redfish is not something we will do.
Exactly, and I guess this goes back to I'm thinking of you, Mita, that you all may not be. You may have an appliance in the data center. You might build your analyzer infrastructure into the BMC, right? Because you're not a hyperscaler that has a consistent infrastructure. You deploy your machines in customer data centers, right? So, I think we want to keep it open so that people like Mita, can do that. I mean, I'm not trying to speak for you, but I'm just saying I respect that this needs to be open-ended. I hope that makes sense to you. And you're on mute, Mita, if you're talking. Maybe she can't talk. Okay.
One more question. Like we have on the GPU NIC and all, we have a RAS API agent, right? For endpoints, there is a similar RAS API agent at the BMC and OS level. Are we calling same name for endpoint agent, or we should give like a different color? Because the functionality of the endpoint is little different than the what is sitting in the BMC for configuration, super logs.
Is it?
Well, yeah. So I think I'll say it again, right? The RAS API definition, Rama, is not yet stable enough that I think we should specify, right? These are RAS API agents. There may be a difference between what happens at an endpoint versus what happens at an intermediate agent versus whatever. But for now, let's just keep it generic, right?
Okay.
Well, and I think that makes sense. And what we'll need to do is just, we updated the drawing, right? Just now. We're going to need to do it again, I promise. So I think that sounds fine.
So I think just make sure I am clear about what Vilas is saying. Vilas, you're saying that this RAS API agent verbiage should not be used here. Is that what you're saying?
No, he wasn't saying that.
Yeah, that's not what I'm saying. I'm saying leave it as RAS API agent. Don't specify beyond that. Like it used to say RAS API endpoint, Anil.
Oh,
right?
got you. Okay.
And so I changed it at Vilas' suggestion, and I buy that. I kind of think it's an endpoint, but maybe it's not, and maybe there'll be a difference. And so I'm open to what I think what Vilas said made sense is let's leave it like this. And later we may change things to endpoints or intermediate points or something, but we just haven't defined the protocol quite to the point where we know that there's a difference.
So one thing is sort of ambiguous now in my mind. You're saying RAS API agent, and we're also saying event management agent. I'm not clear, like two agents sitting in the same box.
Well, one is the bridge to the way I think of it, Anil, is that the RAS API side of this agent, maybe I think what we should do is probably put the RAS API agent on the bottom. But it's RAS API internally here. And then when we go out here, it's whatever you're mapping the RAS API stuff to whatever the CSP wants. And so that's kind of what the IMA is they bridge the CSP's control plane to some stuff we standardize about how the RAS API works in band. And so it is RAS API agent in that it talks RAS API here and out here, but it's an in-band management agent because it speaks to the outside world over whatever protocol the CSP wants. I want to ask Vilas, did I get it? Do I get what you're trying to say?
You got it.
Yeah, I mean, if you look at on the BMC big box, we split the RAS API agent and then the CSP. So CSP RAS API protocol mapping or the BMC wrap that box is really kind of equivalent of an out-of-band agent.
It is. You're right, Anil.
Right.
Yeah. So I think Drew's action is to split the in-band box in the same way as the out-of-band box, right?
Got it. Okay.
Well, okay. But here's the deal, Anil. I was going to rename this one, CSP protocol interface. And guess what I had this as earlier? So if I do this, now I'm back to, this is where I'm going with the BMC side of it too.
Yeah, I see.
So that's
so CSP agent, you can call agent, right? I mean, it's not protocol; it's agent.
Yeah, I think the protocol is
Oh, how about CSP interface?
Yeah, API.
Interface.
You can say API.
It's an interface. It's not a protocol. The CSP protocol is a wire.
Yeah, that's why I said initially. Why are we saying protocol?
Yeah, well, I mean, this is this is CSP protocol on the wire.
Yeah,
right?
yeah. The actual, yeah, the clarity on the arrow is okay to call protocol. CSP interface, CSP agent. I mean, I was calling it an agent, but interface is fine too. We just have to make sure we align our verbiage in the text.
Well, you want me to, so, and here's the thing I don't understand, Anil, and this is where I'm glad you're back. Like, where are we with IMAs? Because at one point there was that other group that was trying to define them, but I haven't heard much lately. You know, the other OCP group?
Yeah, I mean, so loosely, this is already used today in our CSP, right? Everywhere, right? Whatever we are calling CSP interface, I'm just saying invent management agent, but the implementation is very CSP specific,
Yeah, yeah, it is.
right? And today we use it. Now, when we start implementing this framework, then the IMA will be a little more standardized because the input to IMA will look very similar across multiple type of platforms. So today, this IMA, whatever implemented, is very, very proprietary and platform
Yeah.
specific, and it's a mess, right?
Well, and one of the things that we don't have today, I believe, is a really strong connection here. Like, I mean, every device driver is different, and how do I collect errors from them? It's like, you know, who knows, right?
Exactly.
So this is
So
kind of a
today,
new
yeah,
era that I'm really excited about.
right. So IMA today is a very loosely defined, very proprietary implementation, and it's a really kind of a um, it is bloating as the number of heterogeneous platforms are being built. Every time we get some new platform, we have to keep modifying it, updating it. So it's very hard to manage. With this API interface standardization we are defining here, the input of the agent will look very similar, regardless of what platform it is. That's the desire,
Yeah.
right? So the CSP protocol can still change based on our needs, but then the input uh, from the platform should be more standardized.
Yeah, yeah. I think the magenta arrows at the bottom are standardized,
Yes,
and then this is whatever the CSP wants.
right. So I like the RIAS API agent, the way you're defining, putting that in the BMC. Same thing, we can do that there also.
Oh, should
And so
I?
that's where the IMA concept is, right? IMA is a very
Should,
CSP specific implementation.
yeah, is this what you want? And should I make this the IMA up here?
Yeah,
Okay, I'll spell it out later. I'm just trying to make the change
yeah,
fit quickly.
yeah.
Okay, if
And
that's what you want, that's fine with me. That sure.
Like
yeah,
if we look at the implementation, right? Let's say if somebody is choosing out of band, they will have like BMC based services running RAS API agent. They may not have in-band RAS API agent, right? Uh, and that is one implementation. Second implementation, somebody is trying to go with in-band flow. That's where this RAS config and everything is done through in-band management agent, right? Now we are trying to combine both of them into one picture.
or it could be hybrid. Means certain kind of configurations are done through in-band and certain kind of configuration done through out-of-band.
Yeah.
Some error type, some,
That is the
you know,
third combination.
yeah. In fact, most of the time, I guarantee you it'll be a mix, right? Because I don't know if there's any implementation which is completely out-of-band or completely in-band.
Yeah, right now, no, but it may move to that direction. Then, like,
Well,
if you have a
well,
mixed implementation, right? Okay, that RAS config, you may configure some from in-band, some from out-of-band. The synchronization, that is
well,
outside the scope of spec.
I think we'll like most people do it one way or the other, uh, but who knows? You know, I mean, like for configs. Like Anil, I've thought a lot about this, and you know, I imagine that we have a like when Carlos and I went through and thought about how this would work, we have a way to notice that a new machine showed up. That's kind of universal. Everyone has some way to turn up a machine because you need to turn it up and use it. But that discovers the machine, and then as a user gets assigned to the machine, we put a RAS configuration out that's tuned for that user, and then start collecting logs from it. So, I think like when we drive it, we would probably just do it all out of band, but I agree with you that maybe we'll get some error logs in band from the OS. I'd be fascinated to see if we can learn something from the driver that we couldn't get out of band, and so sure, I think the
Yeah,
error log.
that's a very important point, right? Because device driver logs and all that is coming through the kernel inside, right? And you can't get it through out of band. I don't know how you can. I mean, you can get. I mean, somehow that implement doesn't exist today.
Well, yeah, but if we have really good error logging out of band, then it won't matter. Um, but maybe we'll need it. But then the problem is that we'll have a certain percentage of our systems, that are bare metal, and we need a solution that works everywhere. So in that case, I can't count on this because they're not running any of our code, the end user.
Yeah.
So
So basically, what you're defining is a scenario where there'll be limitations. You can do purely out of band, but then there'll be limitations in terms of the observability of certain type of events
yeah,
that
and
are
the
only
same thing's true in man, right? You'll have limits.
exactly. Yeah, exactly. That's exactly what I'm trying to communicate. That in a real scenario, right? Purely out of band, purely in band. If somebody does it, there will be limitations.
Well, I guess what I would say is I can imagine a scenario where for in terms of like customers' quality of life needs me to look at in-band things. Especially if I'm the hypervisor, we could look at it. But I could make a general out-of-band solution that would argue that pretty much allows me to repair my machines.
No, that's okay. I mean, if objective is just to repair the machine, sure, you can get enough information out of band, right? But that is not the only objective of maintaining this cluster, right?
Yeah.
Right. Performance
Well,
monitoring, error event monitoring, trend monitoring, like you said, time series monitoring. I mean, there are all kind of things.
time series you could go out of band.
Yeah. Or the
But
device drivers. Yeah, device drivers complaining something or spitting out some error events. I mean, device driver is a very good example you mentioned, right? These are all running on the either host or on the accelerator itself, right? I mean, and not everything can be pumped out of band.
today, yeah, and we
Yeah.
want to work on that. But I hear you. Okay, I think we're aligned. I think and I want to do as much as I can out of band so that I have one solution that works as many places as possible. But I
Yeah.
acknowledge the stuff that we want in band too, and
Yeah.
each CSP will have to sort that out. I can see though doing configuration purely one place or the other. You don't. I think for configuration, you probably don't need to do it both places. So, well, I take it back. I eat my words the moment I say it. You're right, because, um, an OS may choose to
Yeah.
support a certain PCI RAS feature.
Yeah.
So they may override what the BIOS said initially. So let's work through it. We'll work through the details and we'll figure it out. But I'm coming around a little bit, Anil.
That's okay. So I want to communicate something which kind of, in some ways, bothering me actually. We don't want to communicate a message to the industry that we are trying to enforce an out-of-band solution that requires a high bandwidth interface. Okay, because if just imagine that if let's say we do everything out of band, then the actual pipe to the BMC has to be much bigger than what we do today, like I3C, I2C.
Not really.
Well, I mean, come on. When you have
There are USB interface, there are network interfaces, there are multiple
But
interfaces.
here,
It is not
hold on.
just one thing.
But my point is, no, I don't, because I've done this with an 8-bit microcontroller on a computer before and was able to gather stinking rich error logs. So, but the trick is that you have to apply some thoughtful design.
Drew, when you have a storm of errors, okay, do whatever you want. Unless you do filtering. Unless you do filtering, right?
Rate limiting.
Yeah.
I'm telling you, I've done this before. It's not
Yeah.
that hard. It's really not that hard.
No, I mean, so then, you lose that visibility, right? You can do rate limiting temporarily just to until the storm goes away.
In fact, when I worked at a previous company, when we exceeded the rate of errors, we would limit, and for as long as we had to, it was fine because we were still getting a representative sample of errors, and we could still drive service actions. And in fact, we did some studies with the memory vendors in FMFM that really proved that. So,
I mean, anyway,
so
I don't want to dwell too much here.
None of this requires high bandwidth. There are very few real-time constraints on this. This is imminently doable without a high-speed path.
I beg to disagree, but I just want to share my thoughts that we need to be careful when we try to communicate that everything can be possible through out of band.
It can be. It absolutely can be. I mean, in terms of, now, I'm not talking about, the OS stuff and how the OS is doing. Sure.
Exactly. So you're saying both sides.
But in terms of driving, in terms of analyzing errors and determining if something's broken and driving a RAS action, why not? And like the hardest real time thing that I've ever found doing this, and I've shipped these, was that when you get an uncorrected error, you get a deferred error. At some point, you decide that you don't want the OS to reboot. That is the, and so what you want to do is come back to the infrastructure and say, yeah, you're sick, and do not give this machine back to the customer at the end of the reboot. It's a sick machine. Give them another machine. But the other things, the way RAS features are designed, anything that has to happen really quickly happens in hardware. So you're talking about link width reduction, then too many retries in a row, or some other parameter that may be configurable. That's maybe one of your RAS configurations that you give. And you might preemptively still decide that you want to do a link width reduction because you've seen an anomaly in the bit error rate and you've measured it out here. But if that's the case, you can drive that slowly. If there's a fast action that needs to happen instantly, it needs to happen in hardware, because you can't rely on even firmware to do things at transaction rates. So that's the thing. That is the key, is that firmware, even running that's interrupted, can't race transactions. It loses. So if you need something done at a transaction rate, it needs to be triggered in hardware. But everything else can be triggered at a much lower rate. So what's next?
I think there was some change. I was vaguely seeing some comments about firmware. There's some other drawing need to be changed, or was already changed.
I can speak to that. There are two drawings, I think. Can I delete the old drawing? Or do you want to check it?
Before deleting, just save it somewhere as a reference, or maybe the whole document can be saved as a snapshot of.
About that.
Yeah.
And now if you go back, you can go to version history and see version history. And there's before deleting old drawing. Okay.
Awesome.
So does that work?
Yeah.
Okay. So then the other drawing, we need to update this drawing. This is your in-band.
Yeah, I think based on the what we just discussed, that drawing 8, Once you clean up that one, right, then we can copy paste some part of it there here.
Yeah. Okay. And then the other drawing that needs to be updated is here.
Oh yeah. This is still an old one, right? So yeah.
Yeah. Okay. So I tell you what, I'll do the drawing below if you can do the drawing above, and I'll finish the. I just need to clean this up a little bit to match, right?
Sure.
The
Yeah.
BM. I think what I'm going to say is BMC management agent or something.
Yeah. By the way, in my absence, did we discuss about figure 6? Drew, you and I talked about, right? But I don't know. I don't remember having a discussion in this meeting.
Figure 6. No, okay. Oh, I was going to tell you. So when we got to the PCIe stuff, we skipped it because we thought we needed you.
Okay. Yeah, so I can share the thought process in this section here. So this is part of the system solution architecture, the chapter 6. And so we are introducing this in-band out-of-band together, and defining the various components. If you scroll up, yeah, a little bit more. I'm just kind of giving a background first, right?
This drawing?
So, yeah. So the solution architecture, we're kind of defining at a first of all, very high level here. And the drawing that we were just reviewing earlier, right, is the next level detail, but this is the highest level in call, right? Now, in this section, we are defining each of the box in a little more detail. And so that's what the this in-band agent, what it is, RAS plugins,
And Suke
API.
was kind enough to elaborate some of these. Yeah, because
Correct.
we had one thing when you were gone, we had device firmware and firmware. So we defined, we needed those to be defined. So Suke put a definition.
Perfect. Good. And then after that, I thought that in the context of in-band, we want to make a little more clarification in terms of how the events are propagated in a more standardized way to the kernel. And one of the person from Google, I forgot the name of the person. Sorry, Drew, you. What is name? Sorry.
John Panda?
The person who put together this PCI handling in the kernel.
Yeah, that's John Panda.
Oh, John Pando, right. Is he on the call right now?
I don't believe so. He had
Okay.
By the way, they've copied me on all the code they're checking into Linux kernel. I've seen him and Bjorn Helges, the PCIe maintainer. I need to go back and look at their work, but they're busy working on this. So apparently, they're upstreaming their stuff just like they said, and so we should probably check in with them, make sure it's going as we hoped.
This is good. So
Yeah, good.
the context of this section is it's more of an example because PCI error handling is one of the error type, right? Memory error, accelerator errors, and so this section actually clarifies PCI handling flow enhancements required for in-band methods. And I put the reference to this link to the document that John Pendo put together, and it is already on this Google Drive. So anybody has access.
And I think there were some questions about that, Anil. So, like, Avilas, you mentioned you weren't sure about that. I'm just trying to make sure we resolve that. I'm fine. I'm tracking what you're doing, Anil. I know where the dot came from, but was there?
What is the concern? Sorry, I want to hear what is the concern.
Yeah.
Well, we went through this, what was it, a year ago? I don't know, whenever it was, right? About, PCI SIG is a consortium than OCP, so we just need to be careful what we say, right?
Okay, yeah. So
Oh,
this is not pointing to any PCI spec, by the way. This is pointing to kernel implementation or kernel changes required
I see.
to
Okay.
take the ftrace. So ftrace is a very kernel specific implementation, right?
Yep.
So of course there is a dependency with the PCI spec, but we're not copy pasting any PCI spec stuff here. Now, John may have done something in this document which we need to be careful. So you're absolutely right. We just have to scrutinize this document, and maybe suggest to John that if you're copy pasting anything from the spec here, PCI spec, then let's be careful.
Do you see John's doc? I opened it. Do you see me sharing it?
Yeah.
Okay.
And I think so. It's very hard to not specify the details of the spec when you're implementing in the kernel, but you can do it without copy paste from the spec. I think the concern that was raised was don't do copy paste. Okay, you can do the reference, you can put the section references and all that. So that's what I think what we need to look at this document.
And this is how the kernel sets things by default. So I think the problem was that there was someone making another spec based on the PCIe spec, and they were violating
or copy pasting
pasting
the section verbatim, right? That is not acceptable.
Right. I understand. I mean, given what we went through, we should probably just, describe this and ask someone from the PCIe consortium, hey, is this okay? Right.
That's fair. I think that's a very good suggestion.
I think we did that. Let's talk to Anil.
Okay.
I mean, not Anil. Vilas. Not Vilas. Sorry, Yogesh. I'm sorry. I'm fried. It's been a long week. But I think we did, like when we were working on this all popped up, and we had to hold this back until we cleared it with folks. And so the person that was most sensitive was someone that Yogesh was talking to, and I think this has already been cleared with them. So
okay, cool. Yeah, as long as that's been cleared, then we're good, I think.
So, because we're talking about what Linux does with PCIe.
Yeah, I get it. I just, like I said, just better safe than sorry in this case.
Absolutely. I'm aligned with you. I think we're okay, but we can double check with Yogesh. But I think we already have air cover there. We've already vetted this with them, and we're like, hey, we're trying to define what Linux does, and they're like, oh, that's an OS discussion. Of course, they're not saying rip all the PCIe AR bits out of the Linux kernel, for instance.
Yeah. Okay, cool.
So if you go back, so then what I did here was in the context of PCI handling using in-band, I kind of redraw this high-level block diagram. I made one change. Sorry. I made one change. Yeah, this one, yeah. I made one change here that John didn't have it. I added the IMA box. And also the trace command versus RAS daemon, I think he was he put it a little bit differently than what my understanding. So I need to sync up with John to make sure that this revised drawing is in line with his thinking. And it was just, if you go back to his drawing.
Can I give you an action item real quick to do that?
Yeah, please do that. Yeah. Thanks for, I intend to actually sync up with him. And here, if you look at the drawing, right, from the bottom, the hardware components, the devices, and then the root port is a very abstracted drawing. And then the kernel space in the middle, right? So AER driver, where this is a very low-level driver. So this is like an interrupt handler, and reading the registers, low-level registers, PCI config space, and dumps everything in the ftrace, right? And then ftrace is the one that it is still part of the kernel. And then the AER driver also dumps it in the sysfs, like on the left-hand side. On the left-hand side.
Oh,
So,
left hand.
so AER driver does multiple things, right? Once the interrupt is handled and error information is collected, it does multiple things, right? One is it goes and update the sysfs, which is being initialized during the kernel boot. And it also dumps into ftrace, and also kernel logs, right? Kernel logs, which goes into dmessage.
And I think that was one of the concerns John had, is that these were hard to parse. You know, it was hard to look at the kernel logs. Ftrace was easier.
Correct. So this is legacy stuff. Right-hand side is all legacy stuff, right? I mean, we don't have much control on that, and we don't want to monkey around with that anyway. So the revised version, or the desired space area to focus on, is ftrace based in-band approach. Not even sysfs. Sysfs is another thing that is a lot of legacy here, and at least in our company, the kernel team is very, very strongly opinionated not to use sysfs too much, because there's still limitations on how much information we can capture in sysfs database, and also there's a lot of kernel dependencies, which they're trying to avoid. So using ftrace and then this libtrace event, and then basically getting into the user space, is the approach. The middle approach is the one that we would like to recommend using that. So, and then from libtrace event, again, I'm not expert in this area, but that's why I'm using John's drawing here. From there, either we can do a trace command, like manually tracing stuff. So it's more of a debug. You can call debug or just manual monitoring and all that. But in the runtime kind of flow will be some sort of daemon. And this is a RAS daemon. RAS daemon is one example. Maybe I should, rather than saying RAS daemon, I may want to say, I don't know, a daemon, for example, RAS daemon, right?
One thing I was wondering about with that is RAS daemon already a IMA? Is it an implementation of an IMA? Does it?
Yeah, so we discussed that also, right? So see, IMA is a more abstracted version for a bunch of other stuff. So one of the input is coming from RAS daemon. Let's say devices also are spitting out a bunch of stuff, device messages and all, right? And those are also will go into IMA. Some other CPLD, GPIOs, you know. So IMA agent is the kind of consolidator of everything that goes in the platform that is being monitored through embed methods.
Is IMA a generic?
Why...
Is IMA a generic name, or is it a product or a specification?
Which one?
IMA, is it just a generic name, or is there like a product or specification that when you refer to IMA, you mean that?
Yeah, I'm just using generic term. You can call CSP specific implementation. So there is no spec as such that I know of.
Okay, thanks.
Right. Actually, and that's one thing that I wasn't considering. Because I tend to think of things in fault management centric, but I think you were implying earlier that we might get performance counters and other OS telemetry out of the IMA that isn't necessarily strictly RAS.
Correct. Yes, I mean, that's one thing, right? And then, of course, even in the error handling, right, the error information can be coming out from some of GPIOs in the platform, and drivers, device drivers, you know, the switches spitting out the stuff, which not necessarily goes through RAS daemon. RAS daemon is a very kind of kernel-centric daemon that is registered for this ftrace.
Yeah.
So RAS daemon is just one implementation, right, to collect the logs.
And it's not even complete. It's not complete. Yeah, I can see that.
Correct. So maybe what I will do here is rather than saying RAS daemon, I should say, I don't know, daemon, for example, e.g. RAS daemon, right? So it's one example.
Yeah. Well, and like when we go to the RAS.
Question related to that, right? This seems like a Linux example, but we have multiple OS vendors, right? So how would it look for them? Or
yeah, that's a very good point.
Wording here. And yeah, these layers may not look same in different OSs. So
Yeah.
I'm just concerned about that, because once we say that this is the flow, then but each OS is handling it differently. Maybe we should have a black box and have inputs and outputs, right?
Well,
Yeah, I
another
mean, one thing I can do is just give this as an example for Linux implementation,
Mhm.
right?
yeah.
Because this is, you're absolutely right. This is a Linux implementation, right? And for Windows, I don't know if you want to put anything here, because Windows is again is a proprietary operating system, right? I don't know how much we can.
Yeah, we definitely should not.
Yeah.
Right.
Well, if we do, we'll do it with Windows Team. We can go to. I
Yeah.
can talk to them, but
Fair, yeah.
we do it. It'll be Microsoft doing it, right? But I've mentioned this to the to some folks in Windows, and I think what we can do is go like I think the equivalent would be in WIA somewhere. You know, the
Mhm.
Windows Hardware Error Architecture. So, you know, I've mentioned this to John Strange on the WIA team, and I can circle back with him. But I think yeah, I'm fine. I didn't object to this because it can just be
I
it
think
would be good to call the
adding as
Linux.
an example is okay, I think.
Yeah, Linux
You can put-
example is fine.
yeah.
And then we can work internally in Microsoft and make sure that we're on top of it with Windows.
Yeah.
Yeah.
So you can just put an action item for me here to make that clear that this is an example for Linux only.
Yeah.
And I'll
Okay,
add
I
it
have
in the
one
beginning.
more comment. So for the PCI AR, we can have firmware first as well as OS native handling, right? So whenever we have firmware first, we get the error data in form of CPER. So that path is also not depicted in this picture. Even if we stick to the Linux example, we may want to just add that as one additional parallel path.
That's a good point. From a kernel in-band flow point of view, yeah, I think I can do that. But if you go to drawing, like if you scroll down,
Yeah. Sorry, I was
I
just
think
giving you that item.
I think what you're saying here is that between the hardware box and the kernel space, rather than just showing one arrow here, we can show maybe another firmware layer. But eventually, the AIA driver abstracts out that, like whether it is coming straight from the hardware, reading register from hardware, or is being populated by the firmware using the GHES table, right?
Mm-hmm.
AIA driver gets the same information.
Right,
Yeah.
right.
Shubhada, is that correct? Is that what you're referring to?
Yeah, that's what I'm like. You have the
Right.
PCIe error records from which it will be extracted. Now, I don't know whether it is the AER driver that is going to take it out. It's the OS layer which is going to extract the CPER record and capture the PCIe error record, right?
Right.
I don't think
It is
AER
a
driver
driver.
gets invoked. Yeah.
It is a AIA driver. So AIA driver is actually is a listening mode. I mean, it could be polling also, but assuming let's say listening mode, and there's an MSI interrupt which is coming straight from the hardware, or an SCI which is invoked by the firmware, right?
Yeah.
I mean,
Yeah.
just an example, right? It could be some other interrupt messaging method.
But like in a RAS API world, the AER driver might get it from the GHES or get it from a RAS API endpoint too. We just don't know. Right?
Yeah, so I'm assuming the RAS API is not going to touch this kernel space, kernel layer. RAS API will be sitting on the top of that, like this RAS daemon. RAS API will be sitting somewhere there between IMA and RAS daemon. Because even RAS daemon also is something legacy stuff. RAS API is not going to replace that.
Yeah,
Well,
but if we say RAS API provides CPER as an output, right? If you use the existing layers, then here you're talking about AER, whereas we're talking about having a CPER with the PCI error record at IMA layer, right?
Yeah. So if you look at here, right, there is no CPER clarified here. So output of RAS daemon today is just clear text messages with a receiver error or CTO error. error information with the root port ID and all that BDF. But converting that into a CPER formatted data doesn't exist today. And that's is something can be done, and we should drive toward that. So it should be output of RAS daemon. At least this is what I'm thinking. I may be wrong, right?
Well, I think what I would say is the challenge we're going to have is that we need to reconcile that drawing and this drawing.
Well,
And,
yeah, actually, it is. So if you look at here,
yeah, right. Like the stuff that Anil's showing is the kernel driver or whatever you had in your drawing, right?
Correct.
Yeah.
Yes.
I
In fact,
think
this drawing is expanding, just giving example of PCIe and providing a little more clarity. And then if you go to that big drawing that you have, right, it kind of aligns very well there.
Yeah, I think
right? Like zoomed in version of that, right?
Yeah.
So you're saying this box, and then there's a RAS API thing that goes up to the RAS API agent up here. Is that what you're saying?
Exactly.
So maybe we could tweak this drawing just to show that a little bit.
Yes.
But that makes sense. I buy that. I'm fine with
Yeah. Or could this section be this section could be after going through the big drawing, and then saying, hey, now as an example for the PCI error, this is further zooming into that box.
Can I give you an action item to make it just a coupling of the big drawing and this drawing a little bit more obvious?
Yeah. But the question I have is, does anybody have any preference if I put this PCI error handling, this kind of example, before the big drawing discussion or after big drawing discussion? Any recommendation?
After is better.
After is better.
Yeah, after. I kind of referenced PCI errors as well towards the end of the preceding section. So
okay, good. So yeah, that would make sense, because then we are kind of zooming in further. This is really more zooming in, right? So I think that flow will look good, because when we started with high level, then we go to next level of detail, and then this is even further level of detail, right?
So can I go? Well, this is solution architecture, but I think right here you're saying we've moved this after the big drawing.
Yes, and then put some more context that this is an example for PCI errors handling in the Linux kernel environment.
Oh, I did that. That's what I was writing before. But yeah, the big drawing and tie it to the or make it clear that it's zooming in on the kernel driver, right?
Right.
I'm trying to use the words you were using. Okay, zooming.
Now somebody can ask again, why do we need this level of details in a requirement document like this, right? And which is a good question. I don't know if somebody raised already or not, because I was thinking in my mind, should we really have this kind of this level of detail? And I start thinking, well, Linux actually is a open source implementation, and it is okay to call out how Linux is doing, especially if something we want to leverage on it. V means CSPs, and CSPs do leverage a lot on based on the Linux implementation. So from that point of view, it makes sense, and also it provides further clarity when we say in-band agent or in-band flow, how exactly we picture in our mind the propagation of error information. So it gives that clarity. So from clarity point of view, I think it makes sense. But then, should we have that level of detail here, or should we just point to go chase the Linux kernel documentation and figure it out how it is implemented?
I tell you what, Anil, it helped me to see. I mean, this is helping me because I've been pretty confused about how in-band and the RAS API work together. So this is useful, but I think it might also. I think the other thing we may need to call out a little bit and make a little bit clear is this path from the device driver to the RAS API. That's kind of a new thing, and so I think it needs some description, right? Because like if I just get a random device driver for some card I'm putting in the data center, I don't have a way to get error logs from it.
Yeah, So that's a vendor specific also, right?
Right, but
And
I
then,
guess, but we're saying we want a standard way to connect it to the RAS API, I believe, don't we?
yeah, right. But we haven't really defined anything as such. Now, having
Right.
said that, there are some drivers which are kernel, I mean, which are open source, like Nick, for example. I don't know how much people make use of the generic drivers.
I don't know.
Most of the time, it's going to be vendor specific drivers.
But I guess my point is, we could, if we work with the suppliers, we can say, hey, if you have a RAS API compliant driver, you have some interface that this agent knows how to discover and connect to.
Yes, I think that's a good point. So yeah, we should clarify when we're describing device driver to put some requirement there that the output of device driver feeding into the upstream stack required to have some standard, required to have a standard format.
Or
Now, what it is,
yeah,
what it is something TBD. I mean, we that's a whole new work stream, I guess.
well, it could be part of RAS API too, making it work in band, right?
Yeah, could be. Yeah. Mm-hmm. But the
I
thing
don't
is,
know.
yeah.
Oh, good.
The reason I'm saying is because there are so many device drivers, so many devices. Working through each of the device driver is a whole new effort, right?
Yeah. I mean, well, but I guess that if we have if we have a proposal, we can start running it by suppliers, you know?
Yeah.
Yeah, I agree. It's a pretty big deal. But I also think it would be super helpful in terms of getting errors out of silicon, because today the I/O experience is pretty bad.
Absolutely, I agree with you. I mean, yeah,
So inconsistent, we struggle, right? Because every driver is different.
exactly. Yeah, there's a lot more standardization in the kernel space, but the device drivers is a wide,
It's a wild south. Anything, everyone does their own thing, and I get it. That's just the way things are architected. So if I think it, but I think it would be in the device driver's interest too to get better error data out. And so if they plumb it out, we have the kind of implied contract that, well, we have a way to collect it. We can actually share the data with you from your driver.
Right. Okay, I think I've got few action items here. I'll work on it, Drew, and I'll wait for your drawing to be cleaned up, and then we can.
I think it's pretty. Yeah, I think it's pretty close. I think if I just say BSP management agent, and then I'll define everything else. Did I?
Yep.
Is this okay the way I've done it?
Yeah, this looks good. Yeah.
Okay, Vilas, did I get this right in your eyes? Oh, Vilas is.
There.
I think he left. Yeah. Okay, we're losing people.
Yeah, it's 6 minutes past. His wine time, right?
Yeah. So I think you're clear to take the drawing and copy it up, and I'll copy it down, and we'll go from there.
Okay. Sounds good.
Awesome.
Thank you.
Okay. Have a great weekend.
Yeah, you too.
Thanks. Bye.
Thank you.
See y'all.
Bye.